All right, so we learned a whole bunch of addition reactions with alkenes. Most of these we can actually do with alkynes as well. So let's just go ahead and quickly go over them. So for example, if we have an alkyne, we could add HX to it, right? Normally, if this was an alkene, we would do some kind of Markovnikov addition. And then the same thing occurs here, right? You end up with an alkene, and now you add your X across it, right? So this is kind of a Markovnikov addition. The actual mechanism right here is actually complex. It most likely does not really go through this carbocation because this would then be a vanillic carbocation. And so that's highly unstable. So we won't really go over the mechanism, but we can do this. And then if we add a whole bunch of our HX, we can add excess HX, for example, HCl, we could add 2 of our halogens. And they're both going to add Markovnikov, and so they'll end up on the same carbon. So remember that was our Markovnikov addition, but we also had a way to do an anti-Markovnikov addition, and we can do the same thing here, add HBr, and then our peroxide, ROR. And so at the first step, right, we'll get some of both the trans and the cis. Added to here, and then if we add even more HBr and ROR, we'll get our halogens on the end carbon right here, but nonetheless on the same carbon. And you can think of this as 2 anti-Markovnikov additions. Right, so you can see we can do Markovnikov additions of 2 halogens, anti-Markovnikov addition of 1 or 2 halogens. What if we wanted one halogen on one and the other on the other, right? We can do that as well. If we think about this alkyne, if we add Br2 to it, they'll end up on opposite sides of one another, right? Review these from our alkene lecture. So we can put carbons on different or bromines on different carbons. And then, of course, we could go even further, and we could brominate both of these carbons twice. So some cool stuff there, and you can think about this alkene too. You can add hydrogen platinum to reduce it down, and now you've added your Br2s on different carbons of your alkane. Another thing that we learned with alkenes was our oxidative cleavage using our osmium, or our ozone, our ozone. In this case, in the second step, we're just going to use water. And in this case, we'll form 2 carboxylic acids. You cannot stop at the aldehyde. There's no hydrogens there. So you go all the way to the carboxylic acid. And if you have a terminal alkyne, you'll end up with a carboxylic acid. And then this other carbon will go to CO2, right? So these 2 carbons right here end up as these 2 carbons right there. And then this final carbon ends up as carbon dioxide. So you can see a lot of the reactions that we learned for alkenes essentially follow the same rules for alkynes.